Hello everyone. Thank you for joining us today in this new Rhino user webinar. It's been probably around 3 months since the last one, but we are finally here back with this new webinar. I am Guillermo Varela from Magni Europe, and I'm here today with Adam Buśko. Adam is an architect, and he's working in the lab department at CF Møller Architects, which focuses on early stage design and competitions. He specializes in commercial developments, especially towers, as well as transformation projects. Today, he will show us how Rhino can be used as a powerful tool for competition work. We will see strategies for rapid modeling, advanced use of blocks, visualization in Enscape, and how to produce presentation materials, saving time and allowing us to focus more on the creative side of designing. Remember that in the last 15 minutes of this webinar, we will have some time for Q&A, so you can ask questions in the chat and we will check them at the end. Also, I would like to mention that the webinar is being recorded and will be available on our YouTube channel, where you can find more webinars and tutorials. I think I can upload it tomorrow morning, so if you have any problems today, you can watch it after tomorrow. And thanks again, Adam, for accepting the invitation to this webinar, and please start with the presentation if you're ready. Thank you.
Great. Well, thank you so much for inviting me. It's very nice to talk with you again and to share a little bit of how we do things here at CF Møller. So maybe without further ado, I will just start sharing, and we can dive into the topic of today. So, do you see my screen already?
Yes, it's working.
All right, great. So this webinar is going to be about the competition workflow and competition process in Rhino. So we're going to be focusing on how we use Rhino in this context of doing architectural competitions. And of course, this is just one way to do it. And I'm gonna present for like Guillermo just said, roughly 45 minutes. So there's going to be a short introduction now. Then we're going to talk about, or I'm going to present the workflow, and I'm going to mix a little bit of live examples here and there, because I'm painfully aware that a lot of you would just fall asleep, just looking at the screenshots of my Rhino. That's not the best way to share knowledge. And then we're going to move to some Q&A at the end. So please, any questions are very welcome. And then we're going to conclude this session. So I'm calling you from CF Møller office in Copenhagen in Denmark. We're a company founded more than 100 years ago, but we're very, very much up to speed with digital tools. And today we're going to show you how we do it on the Rhino side. We have around 300 employees here in Denmark, but also in Sweden, Norway, and Germany. We're doing projects worldwide. And here I just posted a picture of a project. Unfortunately, I didn't work on, but I really like, and we just won a bunch of awards for. And I'm part of the lab, which is the early stage department. We have 3 labs in Aarhus, in Copenhagen, and in Stockholm. And here's a picture of some of us, and you can see we're all dressed very colorful, like typical architects, like I am even today. So now let's talk about the competition workflow with Rhino, and just a caveat, or just maybe like a starting sentence, that this is the way that we do it here. And this is a result of many iterations, many tweaks, many seasons of doing competitions. And this is something that works for us at this stage, but also as the software develops, as our way of doing things develop, we are of course updating it. So one thing that I would like everyone to follow up with after this webinar, if you have the time, is maybe to share also a little bit how you do things, because it's always interesting to see how other offices, how other people are doing this. If you're a student, hopefully this will help you to structure maybe your architectural design and presentations a little bit. But this is by no means the one way of doing things. I'm gonna structure everything around this timeline. This is the timeline of the competition, roughly how we do it in here, and it's divided into 4 main sections. So when we discover we define, develop, and then at the end we deliver. And this is something that takes place over 4 to maybe 12 weeks, usually 6 to 8 weeks time. So this is a lot of Rhino time that we're talking about. And the next slide, I just want to show you, when do we use Rhino? So Rhino is pretty much present over the whole course of our design process. And of course, we use other programs, but today we're going to focus, of course, on Rhino. And I'm going to try to show you how we try to do as many things with the software as possible. Sometimes maybe stretching it a little bit too far, but I mean, that's for you to decide. So first, we're just going to start with the templates. So in our timeline here, we're at the very beginning. We're even before we put first line in Rhino. You open up your file, you open up your program, and then the first thing that you do when you're working here with us is that you open your template file. And our template is combining 2D and 3D drawing together. It's on more detailed side. I would definitely say that. But the way it works is that we have a bunch of different categories here, starting with information, and this is where you have, all of your text, grids, the underlying images, something that once you're done with it, you just lock. Same with context. You put all of your context in here, then lock it away. Very important part of it is the building components. Here we specify all of the parts of the building that we'll be working with. But this category here, or this parent layer, only gets it's being started to be filled out once you have some content for it. So where everything starts is the most important layer or group of layers are the sketch layers over here. So this is where you put all of your geometry at the very beginning, and then as you start to get closer to the end design, you migrate some of those geometries to different layers, to the correct layers, so to speak, where the things should be happening. And that way, if we follow this template over all files that we have, then if someone else starts to use the file, they immediately know where things are, and then we can also go in between phases with as little effort as possible. But we're gonna get to that in a moment. We work with blocks, and I don't think we have time to go over all of the details of how we do things in the department, but I'm going to go through the very basics of maybe how we structure things, and that could be helpful for you later on. So once we have a option, so that would be, for instance, an option of option of the building, or the option for part of the facade or something, we put it as a separate layer here in one of the in one of the layers, the parent layer. So if it is a facade, we're going to make a layer here that's going to describe, that this will be, let's say, basic facade. We're going to make a block, and then we're going to hide it, and we're going to switch in between different types of facades just to have some order in the file. That's also important for us because all of the materials and all of the building components are living on their designated layers, and we always assign material by layer. So that way, if you, for instance, want to change the concrete in the whole building, in all of the walls, you just change it once in here, and then you're done. So this is basically the way that we structure the file. So all of the studies are being conducted on the level of overall blocks here in the options at the bottom. But we're going to look a little bit into that when we get to facades. So this is how the 3D is structured, more or less, and then very similarly, the same goes for 2D drawing. So we have quite detailed system of layers here for different building components, and all of the layers have their line weights added appropriately. And then we have also simplified lines. This is where you do most of your sketching, right? And just to give you a quick example of how it works. So, like we have predefined thicknesses of lines and all that stuff. And when you turn your print preview, your file should look, almost as a ready to publish drawing. And yeah, that's the main of how the template works. And just when someone starts a new file, it just starts with this one template. So we can always go back and check what types of how you should name your blocks and etc. I think it's a very useful way to just organize things from the very beginning. Then, if we look back to our timeline here, we're somewhere in the between context analysis and white massing models. This is where we build the first draft of all of the surroundings. Maybe there's an existing building or just the site that we're going to be working with. And this is the moment where we also bring some of the OpenStreetMap data into our file. And we either do it with Elk, or you have a bunch of other browser-based extensions that you can use. I'm not going to advertise any of them, but the one that comes to mind that I used to sometimes use was CAD Mapper. So then you just bring your data in, and then we start with something like this. Then comes the basic analysis, and this is something that we do usually two ways. It's either we do it ourselves in Grasshopper, where we use mostly Ladybug tools, or we use Forma. So these days we use Forma at the very beginning because it's simply easier, and now it has a very convenient Rhino connector. So for the very, very easy and basic things, this is a pretty, I would say, effort-effective way of doing things, because you can just bring in all the context automatically. It's very low effort, and it's pretty accurate. So this is where we start, just to get the basic conditions and to see how the light goes, how the wind accelerates and stuff like that. Then we go into more of the program analysis, the site analysis, where we try to figure out how big the building is that we're actually trying to build here, what the brief stipulates, how high the buildings are, what's the relation between them. And a very, very useful tool around this time is of course Grasshopper, because this is where we do all of our area calculations. And there are two basic ways that we approach this, and one would be that you do some volume, or in this case maybe the maximum envelope of the building or something, and then the script slices the building for you, or like in here where you slice the building into floors, so you already have some thicknesses in mind, and that way you can just calculate per exact floor height that you need. The first option where you do it in Grasshopper is a little bit more time consuming, because you need to predefine all of the heights, and if you want to change it in real time, it also has to be done in the script. And what I noticed in the teams that we're working in, that if the Grasshopper script is not very easy to use, and it's almost like plug and play, that you just put it in your file and it works, then a lot of people would not be using it. So the way that we've been doing it the last few months, or maybe like that, would be, wait, I'm trying to find my file here, but it seems to be closed. Just give me 1 second. I'll just fish it out here. Oh, here it is. So we have a simple Grasshopper script that just takes the names of the layers. You just need to put in, what's the name of your layer. It's gonna output you the area per floor, and then it's gonna add it up per category, and you're gonna have at the end the overall area. And it's very useful because like not everyone needs to be a master of Grasshopper. I definitely am not. I can write some things, but I'm not gonna constantly figure out if everything was calculated correctly. So I would rather have it like this. So we slice the building into floors, and then whenever you make any change to your building, see the areas will be quickly updated. And this is a very, very good way to control your areas while you're doing massing studies. And then even, if you need to change some of the programs and just shuffle them around, you can see that it's going to very quickly, recalculate it, and you're going to be able to see if you're within the brief requirements for the building you're designing. All right, so here we are in the massings. So we did the first analysis. We understood the site. Now we modeled some things, and now we can go into the massing. And the script that I just showed you, everyone should be able to make one with just a simple tutorial. Will allow you to sculpt your volume and have control over the main metrics of the building that you're designing. And here is one way that we started to show our massings. It used to always be a simple white massing, so kind of like a styrofoam one. But the last few years, we started to just make our basic massing models resemble a little bit the physical models, because we're spending a lot of time in those softwares, so it is pretty nice to be able to be in an environment that also looks nice and maybe a little bit more relaxing. And this is also something that everybody knows, because you're used to seeing physical models, and we don't get so many physical models these days. So this is a nice way to kind of bring that back, and also it makes this not so monotonous. So we are around here in our project timeline. So we started doing some massings. Now we maybe have something that we like. So we're going to start testing some facades and expression, and maybe finalize some concepts. So we have some story to tell, but also we need to qualify some of those massings. So this is where we dive heavily into Grasshopper. And now it's going to be a little bit of a humble brag to show you, like what type of Grasshopper scripts we are doing at the office. But it's not something that we do at the lab, but it's something that our sustainability team prepared, and we just learn how to use them. But also for you, it's a maybe nice way to see what's possible in Grasshopper, and that a lot of those scripts, if you make them well, anyone can use them, because I can use them, and I can qualify the massings without someone holding my hand the whole way through. So, for instance, in here you can see that we've been checking the amount of sunlight going into each room of that building, and we have a bunch of scripts that are super useful. And the ones that we're using the most would be the daylight simulator that you just seen on the screen before. We do the daylight factor, which is also something very important in some of the competitions, mainly in Europe. And then, of course, the solar shading and irradiation. That's something that we work with quite a lot in terms of designing the facades. And then the PV panels and the amount of energy you can produce of each building. That's also something that the clients are asking more and more. And then finally, the LCA. This is something that, well, it's not, well, this part is not something that we do ourselves in the early stage competition, but it's something that we are informing our designs with. So our sustainability team, they take our Rhino model and then they run our own LCA calculation tool to give us insights of, for instance, like how much should we, push for a different construction type, or if we're dealing with transformation projects, so we are on track of how much CO2 are we spending with each design decision. This is a very, very neat way to inform your designs, and especially in the day and age that we are today, it's very important to have this, and it's very useful to have Rhino here, because then we can connect with the tools that can calculate it pretty accurately. And then, for instance, wind simulation, that's something that we have to do outside the house. Like we need to get some computation hours, because this is something that's pretty computation heavy. But this is also sometimes where maybe we can lean on Forma a little bit, because they have huge servers and they can do it pretty quickly compared to our own computation budget. All right, and then when we have some facades that we already like, we go into this, I would call it early visualization stage, where we already want to communicate some concepts, and that will be either internally, or maybe we have a possibility to talk with our client and get some input on this, because competitions come in different shapes or forms. Sometimes you will never talk to the client. Sometimes you will be in constant dialogue, or sometimes this is not even a competition, but it's a just idea that you're coming up with for a prospective client. So very often we need to do those quick visualizations, and we found out that this model-like view that we have here, it's a very nice way to do it. And then I will just quickly show you here how we set up our own small model making studio inside Rhino. So here's our fake physical model studio. And for everything regarding renderings, we use Enscape. So and hopefully this will not crash or anything. I'm using only one monitor and I'm used to two, so this is a little bit tricky to show, but hopefully everything will work here. But before this starts working, I just wanted to show you that if you remember from the template, that there was material bank as one of the parent layers, and then here you can see that we have each material has its own, each layer has its own material for the layer. So that's how we work. And then if you copy any of those elements into your main file, it will just be docked into this parent layer. And this will ensure that we will not have any random layers going anywhere around the file. And since we're talking about now visualization and just populating things, one thing that I forgot to mention is that we have this layer on the very top called Enscape assets, because we're working with Enscape, and for some reason Enscape always chooses the layer that it's on the very top. Then we always have it here on top with 3 zeros at the beginning and a very bright color, so we can always see the Enscape assets. And if my Enscape asset is a different color, then I know that it's on the rogue layer, and it's might cause problems. All right, so here you can see our fake model. So this is more or less how we are visualizing these days early design proposals. We have a few views predefined in here, and it's a very, very nice and fast way to visualize certain ideas, because at this stage you don't need to focus so much on the material on the facade, but you need to focus on the thing that actually matters. And in this stage is like, how the shadow hits it, like what are the bigger gestures before you start diving into the detail. Plus, I think it's just like a very fun way to deal with this moment in design, and you can put some fun plastic cars in. But that doesn't only work for facades. We sometimes do it also for talking about structure. I mean, that's of course if we have time for that, but also in the more urban scale. So sometimes we do also those fake urban models, and this is usually very well received because it's just more pleasing to the eye than constantly looking either at screenshots or at just those super polished V-Ray renderings. Not that I have anything against V-Ray, it just Enscape is so much faster. So you can see that this works pretty well. And as with everything, we just have on the side a small library with model making elements, exactly as you would have in real life model shop, with small collection of plastic people, and then we have some cars, and then we have laid out some of the materials that we're using for the studies. So I also think that this is a very nice way to kind of try to get maybe outside of the computer while still looking at the screen. And we'll get the same benefit as when you're doing the actual physical modeling, that you focus more on the volumes and the bigger concept than on actually how things are constructed or anything like that. So this is our little trick of showing those fake models. And then sometimes when we don't have time to go into Illustrator to make all of our concept diagrams, sometimes we do it straight from Rhino. And I think this is also a very neat and time-saving way of doing diagrams. And it's all based on Arctic mode. So we usually have a few types of Arctic mode saved on everyone's computer. So one would be where, like in here, when everything is simply white. You can select the things that you need to be highlighted or outlined. You change the view setting to be different type of Arctic, or you can just change in the properties of the object the display color to be different. Then you use the mesh outline command, and then we have this sneaky trick that then you use bring to front command, and then it will appear in front of your screen, and you can assure that the line will be visible when you put print width on a slightly higher note, and then you have your print preview on. And then when you export it, you can just use export view capture to file, and then you will have one of those diagrams saved. And this is really something that can save a lot of time, especially in the early stages where you want to have a sort of nice looking diagram, but you don't have the time or resources to now go into Illustrator, set up your file, trace the object, do all of those things. It's just kind of like a quick and dirty way to make it work. And then once we have the massing, we're sort of happy with the scene here, we go into facade. So I showed a little bit with this fake model shot how we deal with that part. So like that we just have very simple maybe 3-4 materials on, and we do different types of facades. But now I'm going to just show you a little bit how we work with the facade modules. So here you can see that we just try different types of things. We find something that we like, but it's all based on the block bank. And we started doing this thing, I think like maybe 2 years ago, that if we have a facade type that we like, or maybe there's a competition that we didn't win, and the idea was just very good. You just simply save the facade in this block bank, and then it's just waiting for a better time. Maybe it will be reused in one of the buildings, or maybe it will inspire someone to do something about it. So I'll just quickly show you how we deal with facades. And of course, your building and the facades modules will come in different sizes, but there are quite a few that we see consistently throughout our work. And the main modules that we are working with are 135, 2.7, and 5.4 meters. That's usually the ones that are, well, the most popular. So I'm just going to quickly show you our very simple facade workflow here. Oh, I got the wheel of doom here. Maybe I will not show you. Maybe I will show you in a moment. But basically, the way that we're trying to work with this is that every facade module from very early stage is a block, and we give those blocks names that are kind of easy to trace afterwards. So you can figure out your naming system yourselves. But the funnier the name, usually the better. And we just exchange the blocks as we go. So I'm just going to quickly show you what I mean here. So let's just make a very quick fake facade here. We're working with 4.1 floor height. So now we have this wall of modules. So this is how it starts. So if we have a more complicated volume, something like this, first you just clad it with those tiles, and then we simply use the replace block command, and you pick a block of the same type and the same width, and then it's exchanged for something else. And then as you, for instance, study different types of it, what we do is we just make, maybe I'm gonna exchange it again for something that's more symmetrical. Maybe for this one. Okay. So when we study different facade types, usually we start with something simple like this one. And then based on this facade, I will make a unique block. So we use block tools, and I think it was developed by one of our colleagues. It's available on GitHub, but also this is part of the new build of Rhino 8. Just we did not update yet, so we're still using this one. So based on this block, we're making a unique copy, and then we're making changes to that one. So let's make it something rather funky here. So you could see the change. Nothing yet is changed in here, but you can choose all of those blocks, or maybe just bunch of them to replace. We replace for those guys, and now you can see that we exchanged a bunch of blocks, and it's not a laborious process where you need to go and exchange each one of them. And then from this point to get to a study on the whole building, it's very quick. And then you can make very quick changes on a larger geometry and actually see how this will work when you render it in proper lighting conditions, because that's the biggest part of the whole facade game. So when we look at the next part of our workflow, we get the facades on the volume, and now we start to do a proper study. And you just seen how we exchange the blocks, and with that method in mind, and you can even see here in that study that we did, is also 5.4. We can quickly exchange blocks and then set a few cameras, and then you can make a very, very well informed decision on how, first of all, how your building looks, how it will perform in terms of daylight. You can run some analysis, but the most important, you can just see. You can have a visual of what each of those changes will do to the building. And at least for me, that's a very nice and satisfying part of the whole design process, because you can very quickly get quite dramatic results. And then once we have our facades on, we have something to work with. Then it's time to get some animation in. And similar to all of the libraries that we're using, those are made within the department, and then it's just something that we found to be working on different projects, and then we just collected those ensembles of things. I'll just quickly show you. For instance, if we're doing an office, instead of always laying it out from an empty piece of paper, we can just grab some of the desks that have been used before, and they're very nicely laid out. Similar with those lounge areas. We keep it in the file with some rendering reference on the side, because that's a very good way for you to pick the ones that will actually fit your scene, because with Enscape assets, they're not always representing one-to-one what you're going to get when you render them out. So this saves us a lot of time in actually picking what we need. We have like whole meeting rooms saved in here, so you can just grab them and put them into your design. Same goes for landscape groups, seating arrangements, people, other things that you might use in your design. So I think a very useful way to look at what you're doing in Rhino is that it's not that you always need to do things from scratch. That very often you can reuse things from previous projects. And if you are organized in terms of, like, for instance, which layers is it, or like, is it actually in one file, or you always need to go into a project that you did before and fish for it, if it's organized, then you're going to use it. If it's not organized, then it's going to disappear. And then the work that you're doing will never be benefiting anyone in the future. That's something that we always try to look at here. And then one of the last things that we do before the competition material is made or sent out is putting textures on things, and that's a very big task. And I think I said like 10 times already that we always put material per layer, and that's simply very useful and works for us. And then if you do this, then you can easily bring things in between files, and they will land on the correct layer, and then you will have the same material. And in terms of materials, we start very simple. So we always try to find things in Enscape first, and only if we cannot find the material in Enscape in this predefined list of like 400 something, then we go for the custom material. And for custom materials, what we did is that we have downloaded a bunch of Megascans materials back when Megascans were distributed for free. And we just made Enscape materials that are saved as those bunch of cubes. And the way that you just do it, and you grab the cube and you can just copy it into your file, and then just start using it, and it will drop on a proper layer in your file. I'm going to try to turn on Enscape in here, but it might take a while. So I'm going to show you the other options in the meantime. And something that we started doing recently, because we're trying to leverage some of the AI capabilities in terms of visualization as well. If we cannot find the material, either in Enscape library or we don't have it in our custom library, then we go to Midjourney. And in Midjourney, you can, using the tile suffix, or appendix, you can generate seamless textures. So we just, put the description, the prompt of it. You make it seamless, and then you can put in a reference, and then usually the results are pretty good. So we get a material like this, and then I use ChatGPT to give me the normal map or the height map and a reflection map. Usually, it's also pretty good at this. And then when we render it, the results are pretty okay. So let's see if my Enscape is on. Not yet, but well, what you would see here is just a bunch of textured cubes. And then we're trying to keep as many things within Enscape as possible, right? So within a Rhino, so most of the renderings that we're going to do are also Enscape. And these days, so this is a zoom in on a bigger rendering that we're recently doing. Enscape is pretty good when you look from afar, but if you start zooming in on people, you can see that they have this quality that they look like they're carved out of wood or soap or something, like they're not very realistic. So what we started doing lately is to work with upscalers. So we mostly work with either Magnific AI or Krea just to put the image in. And you can see that the difference is quite significant. Like this person that was very much improbable now starts looking like an actual human. And some of the clothes or other items in here and the greenery starts looking better. So that way, you see like how making things rather simple and repeatable, you can get to a nice result. And then by the end, most of the drawings we these days also trying to produce within Rhino. And like I shown you before, using the template when you have all of your layers with predefined line thicknesses. And now that Rhino from, I guess, the version 8, it supports hatches with transparency. Then you can do most of the things that you will be able to do in Illustrator. We're only waiting for the draw order to be implemented at some point, and then we have everything, right? So like at this point in our competition timeline, we're closer or almost at the end. And then the last part that we do here is the data exchange. So if you're finishing up with your project and hopefully you won it, then the next group of people will come. And in our case, our BIM team, they work in Revit. So then we need to use the data exchange to migrate the building into the next phase. And for us, keeping the model rather tidy, and what I mentioned at the very beginning, looking at the template, that at some point things will migrate into their proper layers. It's very useful for the later stage of the project development, because they will be able to, based on the name of the layer, define what the object is in Revit, and that kind of closes the whole loop on the competition workflow. So we started from a kind of well-defined but maybe slightly over-defined layer template that has some wiggle room inside of it, and then we're ending on the same template that just feeds to the next stage of the design. All right, so this has been 45 minutes now, as we planned. So now I will take questions if you want to know any specific things regarding our workflow or commands that we use, or whatever favorite UI tricks from Rhino. And that's the great time now.
Thank you, Adam. It has been amazing. And yeah, there have been a lot of questions in the chat. I have been trying to answer them, but yeah, I have tried to keep the most repetitive ones. But yeah, the presentation has been great, and I think it was really interesting for many people that really like the tricks with blocks. I think it's super interesting, and it's something that many people don't use in Rhino. And I think this example shows how to use them and what's the benefit of using it. I think it's very interesting.
Yeah. And I think the benefit that I didn't talk about is also that it kind of looks like you're working with Legos, and I love Legos. So then it makes it a little bit more fun.
Yeah. No, but it's really nice the way that you organize all the files to keep everything in very handy to use every block and every all the tables organized, all the greenery. So it's really you are saving a lot of time in every project. But yeah, about the question that the people have asked, I see that many people is writing now more questions. But the first one from Afonso was because in your template it was in millimeters. So he was asking
Yes.
if you are working in millimeters in all the projects, or it's
Yes.
because of
So
something. Yeah.
for most things we're working in millimeters, but there is this tricky moment when you change scales. When you go into urban scale, from millimeters no longer work very well. So we're trying to work in millimeters, but there's no certain threshold that we switch. Um, it it gets sometimes a bit annoying with the area calculations because you always need to remember to divide it by certain amount just to get the square meters. But yeah, we're trying to work in millimeters. It's at some point it's even easier for me, for instance, if I'm working with a building, to type in, let's say, 3,800 on my keyboard than to do 3.8. So I think it's mostly the precision, and always when we're discussing building elements, it's in millimeters. So the door is 900, it's not 09. So
Yeah.
hope that answers the question.
Yes. Thank you. I'm checking the new ones, but the other one that many people has been asking is if it's possible to share the presentation on any of the template files. I suppose it's not possible, but
Unfortunately, no.
yeah.
But I try to share as much as we can in here, and then you can build your own, and some of it you can just see more or less how it's structured. And I think I would encourage everyone to make their own template, because that is a way that you actually understand what it is, how to use it, and what works for you. And the same goes for aliases. Very often people at the office ask me to share my aliases, my shortcuts with them. And I say, like, of course I can do it, but please type them in yourself, because that's the way that you will make them yours. And some of my aliases make absolutely no sense to anyone, because for instance, I don't know why split is Q in my Rhino, but it's always been like this since I remember. So yeah.
Yeah, I totally agree. That's what I answered before, because if I have this file, this template, I won't use it. It's going to be harder to recognize all the layers and use them correctly than creating it myself. But I think at least watching the webinar and see how you have it organized, you can have an idea of how to organize it with the structure for 2D, for 3D. And I think that totally makes sense to create your own depending on your projects. The other one was about the blogs, but I think we talked about that already. And the other one was if you are using also work sessions to manage large projects, and how do you work in your team?
Yeah, that's a great question, and we were just talking about this yesterday, because we're constantly reevaluating the way that we do things, and we used to always work with ton of work sessions. I mean, not a ton, but the status quo, or let's say of 2020, 2021, would be that the context is one work session. Then the landscape will be separate. At some point, the facade could be separate, and then it resulted in a lot of mismatches, and also the work sessions are like, you need to constantly update them and make sure that they are working. So what we found out that with mostly working with Enscape, our files became way lighter. We work with proxies, so all of our greeneries are proxies. Our geometries are getting less heavy, and we started to make the files as one single file. And also, I know for a certain size of team, it would make sense. But since our usual team size would be 2 architects, maybe 1 senior architect, and 2 to 3 interns, usually you can split the tasks in a very defined way without stepping on each other's shoes. So I would rather get someone to work on a whole landscape layer and say that this is your layer, and then we're going to merge the files rather than using the work session as we used to do it before.
Okay, yeah, that's interesting. And the final file is huge, or it's manageable?
I mean, just looking at the competition we're doing right now, like we never go above 300 megabytes, which, standard laptop now has 64 gigabytes of RAM.
No,
so it's absolutely no problem. And I remember like 10 years ago, Rhino file used to be at least 300 at the end of the competition because certain things were not as optimized as they are now, and we didn't work with rendering proxies. So it's also a matter for me. It's a matter of speed. Work sessions tend to slow down the work a little bit. In this size of team, of course, like there will be projects also when you're working with external consultants, for instance, when someone is working on I don't know, part of the building, or it's a very complex thing, then it's a different story. But I'm talking here about buildings that are smaller than 100,000 square meters, and we're only working on them within our organization.
Yeah, and see here a question from Baltasar about this. He was saying that he's studying and he has learned Rhino by himself, and at the end of the semester, his files are giant and he can work with them. And it's a problem that we see very often in tech support here in mainly Europe. So using blocks is probably a great option, but also keeping the file as organized and simple and clean as possible.
Yes,
but many people have this problem.
Yeah, I definitely would encourage like using blocks, and then I would make almost it a habit that you purge, unused materials, all that stuff. Maybe not layers, because if you're good with your layers, you don't need to purge them so often. But just, I don't know, if you guys like making things with Arduino or something, just make a button that says purge and just hit it, every half hour. And when you're doing a save, you should be making a purge. I think that's a good way of looking at it.
Yeah. And if not, you can always send it to us, and we can check it and see what's not working. Because it's like that, a huge project like the ones that you're doing, probably urbanistic and with many buildings and everything, it's 300 megabytes. That's something that you can manage. But sometimes it's like, no, my file is 2 gigabytes, and it's because probably something is not correct, and it's possible to improve it.
Definitely.
I see many people asking if the webinar is going to be available, the recording, and yes, I have said it already, but as many people have joined lately, I will try to upload it tomorrow morning, and I will send you an email with the link to see in our YouTube channel, so it's not a problem. And yeah, the next one is about blogs again that I missed it. Is that many people was asking, how do you keep all the base point to insert point to replace the blocks always organized?
That's a great question. And we have, so the rule of thumb for all of our projects and in terms of facade is that there's one way of putting the insertion point. So for the facade, let's say the insertion point is always, when you're looking from the outside, is on the bottom left. So on the inside of the building, on the bottom left, that's always your insertion point. So that's the rule of thumb. But of course, sometimes someone will have their C-plane rotated, someone will have something different in their file, or someone will simply have all their snaps on and they will snap to a different thing. because that happens. So what we're trying to do when we're doing iterations, when things are not so clean, that we always go from one block and then we make unique. So if you make a unique copy of a block, then you can be 100% sure that your insertion point and your world coordinates will be the same. And this is something that really saved us a lot of work recently, because I remember back in the day when we always used to make a new block every time. Then if we were changing blocks in between files from other people, then very often you exchange and all of your facade modules are rotated 27.2 degrees or something. And then you don't know why, because someone just made it in a different world coordinate. So I would say first, make a rule of thumb that there's always a rule for instance, like, I don't know, it could be like we do it, bottom left, and just remember that and do your point there. If you're in doubt, make a unique block, then you know, then you cannot fail.
Yeah, I think the bottom left is a rule for everyone at the end. It's
Yeah.
the one that everyone uses, and unless there is something special about it. Is everyone I know uses that as a reference, and I think it works great. And the next one is if you create the 2D drawings also in Rhino, or if you export your model to Revit, and how do you export it to Revit?
One more time?
Yeah, about if you create the 2D drawings in Rhino too, or if you move to Revit, and how do you move your model to Revit at the end?
Yeah, so I would start with the later part of this question. Mm-hmm. So as I showed on the last slide, that we use the data exchange by Autodesk to migrate things. That's for now the best way of doing it, and we do it. Well, it's data exchange to ACC to Revit. That's basically how we want to do it. But sometimes, like if it's smaller things, we might find some more sketchy workarounds. But that's the working method that we use. And then all of the plans, we make them in Rhino. So we're trying to get our line thicknesses to represent, so they print well. So we have settings for we have overall settings, and then we just adjust the printing to fit a scale. So for instance, like we're working usually in 1 to 200 drawings, but if we're going to then output in 1 to 500, then the plot lines will be, proportionately thinner, just to fit with that. But we had quite a lot of success with this method. We use layouts, and then, you lay out all of your things on separate layouts, print once, it exports one nice and clean PDF. That's a pretty good way of doing it. Before that, we used to always take our plans to Illustrator, then we would do all the line thicknesses and all that stuff. But it just takes so much time, and each change also takes time, because then you need to go back to Rhino, export it, change line thicknesses, all that stuff. So that's how it's done.
Okay, thank you. Yeah, I was checking. That's some questions are repeating and not about this one too. Yeah, because that one was if you use Make 2D, or I was suggesting, for example, using clipping planes, that now you can extract the 2D drawings. So yeah, that's probably the two main options.
Those are the main options. We sometimes also use the section tool, which is pretty handy, because then you just draw a line and follow it. But to be honest, when you're doing a competition, very often you would just draw your plans almost separately, right? Because it's your 3D and 2D will not always match 100%. This is for what BIM is for. And here we can, just like have some wiggle room in terms of that. 3D is mostly to get the base principles, and then get the renderings and all that stuff. Yeah.
Okay, thank you. About that one too, is if you use any algorithm in Grasshopper to automate the 2D drawings. I think it's complex.
No, not. I mean, the only thing we do is always is the area calculation in Grasshopper, but from what I found in the very early moments of the project, we're just using Grasshopper as a additional tool. Like we don't rely too heavily on it. Also, we're not doing too many projects that require a big level of parametric knowledge. And we're not very often doing crazy facades. So then also we don't need to do that in 3D, but in 2D definitely not. We do it a little bit more old school, I would say.
Okay, yes, I was just checking here. I missed the question. I'm not sure who asked. Because the command to create the unique block, you say, I'm not sure how you call it, make unique. And in
So
Rhino
this is
8, it is create unique block. So
exactly.
Okay. The name is not exactly the same. Someone was
So
asking.
like that's what I'm saying. Like the one that we're using is it's made in CF Møller long time ago. And the command is make unique, and then the one that you have is create unique block, right?
Yeah. Thanks for the suggestion to create it, because I think it's really handy here. And in your example, it really shows how to use it. So it's great.
But I have to say, like, it's such a nice feeling to know that, something that our company suggested actually is in the software now and people can use it. So yeah, it's very, very satisfying.
No, but for us too, we always try to talk with the companies and to the users, because it's the way that we can find how to continue with Rhino, how to improve it, and how to create new features. And if it's not talking directly, it's in this course, so it's always like that. Another one was asking, because the renders in Enscape are great, the ones that you have shown, but some other asking is at the end if the renders for the competitions are made internal or externally by a this company using Enscape or another software.
It's a very good question. So like what I showed you by the end is that some of the renderings we do in Enscape, and these days it's Enscape and quite a lot of AI on top of it. So you don't see that it's so Enscape-y. It doesn't have this trait of the real-time rendering engine that you used to see in those types of renderings. So if it's maybe not a super high tier competition, or if we have a very good grasp on things, and then we just know how the image should look, and we just can do it internally, then it's made in Enscape. Otherwise, we try to hire someone external, and then we always share a Rhino model with them. And then actually the fact, okay, I'm repeating myself so many times, but material per layer comes in handy, because then you have the name of the material usually in the layer, and the rendering company knows exactly what we mean by that. But also, like, we usually work with the same guys, so they also know how we work. But I've never had any issues with any rendering company accepting a 3DM file. So yeah.
Okay, so thank you so much. I think that's all. There are a few questions that probably I missed because the chat is crazy today. And I'm sorry because some people hasn't been able to join the session because we reached 300, and I think that's the limit. It doesn't happen very often.
Damn.
But yeah, I think at the end they have been able to join, and if you haven't been able to check all the presentation, you can check it tomorrow in the recording. So it's not a problem.
Awesome.
Thank you so much, Adam.
Thank you so much for inviting me. And like, it was really great to share what we do. And like I said, if you guys wanna reach out, maybe there's some way that I can leave my email also in the show description or something. Because I'm always looking for new ways to optimize the process. And it's always nice to hear from other people how they're doing things. And it's nice to see that how the software is evolving together with how the industry is. So yeah, thanks again for the chance to share what we do here.
Thank you so much. Have a great afternoon.
Yeah, you too.
See you all.
Hi.
Bye bye. Thank you.
Bye.